Linear equations, identifying slope and y-intercept. What is the template for a linear equation? A linear equation is typically written in the form y equals mx plus b, where the coefficient in front of x, this m, that represents the slope, and the constant that's being added represents our y-intercept or our starting point. In this video, we'll be exploring different linear equations and trying to determine which element represents the slope and which represents the y-intercept. Problem 1. Let's find the slope and the y-intercept for this linear equation. First, finding slope. Which of these terms represents the slope of the graph? Notice that here's our x, so the coefficient, the term in front of it, this 1/3, that's going to represent our slope. We have a slope of 1/3. Which term represents our constant? This 4 that's being added to the side, that's going to be our y-intercept. The graph starts at 0, 4. Slope can be further broken down to a change in y over the change in x. So what's the change in y for this slope? The change in y is going to be the 1. And the change in x is going to be the 3. So the change in y is rise 1 and then run 3. Problem 2. Which component of the linear equation represents the slope? Notice that even though this is not in order, our x is located over here, so the coefficient in front of that, this 4 fits. This represents our slope. Which component represents our y-intercept? Notice that the -7 is being added by itself, so our constant -7, that will be our starting point. Taking a closer look at our slope, which component represents the change in y? The 4 represents the change in y, and which part represents the change in x? The 5 represents the change in x. So it's rise 4, run 5. Problem 3. Which part of the equation represents the slope? Locating our x, the term in front of the x, this 2, is going to be our slope. So this has the slope of 2. Which term represents our y-intercept? Notice that this 6 is being added to the side. So this graph has a starting point at 6. Let's break down the slope into its two components. What represents the change in y for this slope? For a slope of 2, our change in y is going to be 2. But what's the change in x going to be? Notice that if there's no denominator, we can treat each slope as being over 1, because dividing by 1 doesn't change the value. 2 divided by 1 is still 2. Problem 4. Which part represents the slope for this linear equation? Finding our x, you might notice that the 3 is right in front of the x, so you might think our slope is 3. However, if you look closely, notice that it's subtracting 3x. This negative, this minus sign is attached to the 3, so our slope is actually going to be -3. Now, which part represents our y-intercept? Notice this constant that's by itself. So our y-intercept is going to be at 9. At 0, the graph is at 9. Taking a closer look at our slope, what's the change in y going to be? So the top of our ratio is going to be -3. And the change in x, since the graph doesn't have a denominator, we can put this ratio over 1. Because -3 divided by 1 is still going to be -3. So we have a slope of -3 and a starting point at 9. Problem 5. Which part of the linear equation represents the slope? Locating our x term, do you notice that we don't have a coefficient in front of x? We don't have any numbers in front of x. So if there's no number in front of x, what's our slope going to be? When there's no coefficient in front of x, we can always treat this as having 1x. There's 1x here. So the slope for this graph is actually going to be 1. What's the starting point or y-intercept going to be? The term that's by itself, even though it's a fraction, our y-intercept is going to be 1/2. So at 0, our y-intercept is going to be 1/2. And breaking down the slope, what's our change in y going to be? Our graph is going to rise up 1, and the change in x is going to be, it's also going to be 1, because 1 divided by 1 is still 1. So the graph is going to rise up 1 and run 1. To summarize, if we want to find the parts to a linear equation, the slope is going to be the coefficient in front of x, and our y-intercept is going to be the term that's added by itself.